Hello everyone. I welcome you all to the class lecture 2 of the design for sheet metal. So in this lecture we are going to study about the aluminium, which is most commonly used in almost all sheet metals. So from the heading itself we can able to see one thing: aluminium, the weight saver. We already know that aluminium is a lightweighted substance. So aluminium revolutionized modern engineering by offering a compelling alternative to steel, significantly reduced to mass with excellent structural performance and excellent corrosion resistance is one of the most important peculiarity of this aluminium. So, what all are the important properties of aluminium? First of all, superior strength to weight ratio. Aluminium is approximately one third the density of the steel, yet specific alloys can match steel structural performance, making every gram count in weight critical applications. For example, we can use it for having applications that require excellent conductivity that includes both thermal and electrical conductivity. It is next to the copper, right? Now, next one is efficiency. It is used in the manufacturing of all automotive components due to its lightweight, because this aerospace application and automobile applications we require very lightweight components that will consume less fuel. So aluminium directly translate to cost and emissions savings. Next one, what all are the alloys of aluminium? So pure aluminium is soft. By giving some alloying elements like magnesium, silicon and zinc dramatically enhances its mechanical properties for specific engineering demands. First of all, we can see 6061 alloy. It is a high strength and excellent weldability alloy, the workhorse alloy for structural building frameworks and machine components. The next one is 5052. It is having superior resistance to saltwater corrosion. It is preferred for marine vessels, fuel tanks and coastal architecture panels. Now the third one is automotive and aerospace, that is fuel edge skins, car body panels and window frames. The aluminium delivers form, function and weight savings. The next one is copper. We already know it is one of an excellent electrical conductors, or we are using the coils for making electrical components or wires. So copper has been central to human technology for millennia, and its unmatched electrical and thermal conductivity ensures it remains indispensable in modern engineering, electronics and infrastructure. Now, how it is going to be special from other? It is a conductivity specialist. Copper offers the high electrical conductivity of any commercially viable material, combined with excellent ductility and formability for precision manufacturing. It is used for mainly electrical wiring because of its low resistivity that minimize energy losses. Now the next one, it is going to use for heat exchangers because of its exceptional thermal conductivity, and it is also used for making fine wires because of its ductility property. Now, we can able to make a comparison with the steel, aluminum and copper. Steel is having highest structural strength and load bearing capacity at lowest cost. So because of this property, it can able to choose for heavy duty frameworks and supports. In the case of aluminum, it is best for weight critical applications that requiring corrosion resistance like aerospace, automotive and marine industries. Next to copper, it is going to be used for mainly electrical and thermal transfer, essentially wherever the conductivity, not strength, is the primary design driver. So hope all of you understood. Now, what all are the important factors affecting the selection? The first one, for the sheet metal process or sheet metal operation, we are going to check the formability. What is formability? It is a product geometry and complexity determine which material can be practically formed or stamped. The next one is environmental exposure. How it is going to be act based upon the environment exposure. Now, moisture, chemicals and temperature extremes directly influence the corrosion resistance requirements. The third one is life cycle cost. Initial material cost must be weighted against the maintenance, replacement and end of life recycling value. Next one, we can able to take the surface of the material processing. So beyond the surface, how we can able to process it. So the final performance of a sheet metal is shaped not just by composition, how it is processed. Post-processing techniques unlock the properties beyond the raw material's natural limits. The first one is heat treatment. We can able to perform the annealing, quenching, tempering to adjust the hardness, ductility and internal residual stresses to meet precise engineering specification. The next one is welding compatibility. Not all alloys weld cleanly together. Understanding the metallurgical compatibility prevents metal failures or weld failures and structural weakness. Next one is another important, the structure of the internal grain. So controlled grain size and consistency in determine surface finish quality, dimensional accuracy and fatigue resistance in service is going to be one of the most important factor. Next one, we can able to take a toolkit. So what all are the summary? How the sheet metal property is going to match to our requirements, balance the trade-off. Finally, we are going to apply the designation standard based upon the requirement. So the future trends in sheet metal is can be used for sustainable recycling because it can able to be reducing energy consumption by 95%. Next, we can able to develop new advanced alloys which is having high strength, ultra lightweight alloys for enabling designs. Then we can able to do the simulation using digital like FEA and AI driven simulation tools. For what purpose? To predict the metal behavior and failure mechanisms or modes before the single piece is cut. Now we can able to conclude this session by thinking we want to build smarter, to be select with knowledge, test with rigor, finally build with a purpose. I hope all of you understood. Please feel free to ask me for any clarification. Thank you and take care.